Another useful thing to know about is camera projections. So what that basically is, as just a reminder here, is that you have a camera, that camera is projecting whatever texture it is onto a surface, and the cool thing about that is you don't need UVs. So here's how you would go through the process of setting that up. Let's say that we have a new camera. Let's say camera 1 right there. And we're going to call this our front table cam, I guess. I'm talking about doing a projection on the camera that's on this table right here. So what if I wanted some decals along this ring and I want to make that in Photoshop without doing UVs? Well, that's very possible to do. Let's first of all turn everything off except for that camera. So highlight that guy just so I can see where it was in the network. Get rid of everything else. And then all we do now is we have the front table cam, right? Let's go ahead and highlight this network, spacebar F to frame that. Now on the camera itself, we go to the view and we set a resolution that's equal to our texture map. So in this case, our texture map, let's do a 2K resolution, so 2048 by 2048. And I'm just going to zoom in here like that. Also on the focal length, change this to something like 100 millimeters. It's going to get rid of some of that distortion, which occurs at a lower focal length. And so I found 100 millimeters is usually pretty good for most circumstances. Okay, so now that we have that, let's go ahead and also just turn off all of our lights real quick. And then we'll just use this test HDR so that we can render this really quickly. We're going to make a test render of what this is right now. It's a redshift render view. And let's select this front cam and press play. The idea here is that we want to create a render that will then go to Photoshop where we can overlay everything that we want. Now right now, this also is being overridden by the resolution set in our render settings. So let's go to this, uncheck override camera resolution so that now we actually have a square render happening. Let's go ahead and zoom in a little bit more. So right about there, go back to our render view and let's render out this shot right here. Once you find yourself in Photoshop, the next thing to do is to do whatever sort of projection you want, just draw over the render. And then you'll need two things to export. You'll need the mask, which is just a black and white version of whatever new elements you just added. And then you need a color as a separate image as well. I'll save that out and show you how to put that in the shader. In general, it's a good idea to have a separate shader for whatever you're projecting a camera onto. The reason why is because let's say that this is a steel shader right here, and there happened to be something else that was steel behind this object. Well, if you do a camera projection, it's going to project onto any object that's visible within the camera's vantage point. So it's a much better practice, just to prevent yourself from creating weird stuff, to create your own shader in the areas that have the projection that you want. So that's what I have going on right here. Front steel cam plates. That's a new material that just has the front section right there. The reason why this is weird is because I decided to rotate it down here. So don't worry about that. But anyway, we have that. It's right there. Front steel cam plates. And the setup is very simple. All you need is the map. I have the mask loaded in. The camera picker right there. And let's see what that does. And now we should see something like this. So at that point, we know that we're successfully projecting onto the surface. This is just information that can be used like any other piece of information within this shader tree. So now let's say that I want to make this into some kind of iron as an example. Well, I can use this perhaps as a bump in that iron, maybe like a little decal or something. So let's go ahead and make a bump map. And I think you get the idea. We just do this kind of thing into bump, and we can get something like that. Maybe, yeah, right, there we go, right there. Another great thing to know about is baking texture maps. If you're doing an ambient occlusion pass, or maybe you want to bake this out for a game engine or something like that. It's very easy to do. All you need is you have the geometry right here. This is the sphere that we used all the noises on. And if we go here to the render map section, just check on bake render map. You can drag in the objects that you want to include. There's the UVs, say the resolution that you want, and then specify the output in this common file prefix. So here I just have a JPEG image, and if I render this out, I get something like this. This is looking at the UV view, and again, that's just a texture map that I created. If you don't want to save out the beauty pass, you can do another pass instead by going to the AOV tab right here, and then clicking the plus icon. I chose emission, so that's going to isolate just the emission channel. And then you do another render, this time in the redshift render view, and you can go right here and select whatever pass you'd like. Once you do that, save the image out, you're good to go. As far as other miscellaneous things go, let's talk about PTEX and what that's all about. PTEX is developed by Disney, and the way it works is that it takes each face of the model and it assigns each face its own texture map. And it creates this atlas of all the different textures for every single face, and it turns it all into one file. Now, even though this looks like a regular bitmap that we use with UDIM, it's not the same thing, and it doesn't work in the same way either. PTEX is its own format, and it's understood natively by applications that know the PTEX lingo. PTEX is also understood by the application, but you can't paint directly on it in UV space. And so unlike UDIMs, where we have sections of a mesh that are laid out and it's fairly human readable, PTEX is not that way, so you can't just paint on a PTEX map like this. And one thing that's great about it, though, is that MIP mapping, that is the ability to have multiple resolutions in one file, is automatically generated within the text file. So you can see that visually here. We have, let's say, the highest resolution here with all of these texture maps for every single face. And then as we go up, these texture maps get smaller and smaller until we have the lowest resolution existing at the top right here. Now, I already mentioned a couple of the pros and cons with those 2 points, but let's keep on talking about the pros and cons. The pros is that PTEX does not require UVs, and that's one of the main reasons why Disney made this in the first place. Also, file management is easier. You need one texture map for an entire mesh. You might not be using multiple UDIM tiles for things, and so it just makes it more convenient, I suppose. However, we also have some significant cons, and it's really not the silver bullet that Disney tries to sell it to be. And so with PTEX, getting enough resolution can cause slow performance. It oftentimes will start dragging down the scene as you paint on it if you keep cranking up the resolution. It's not friendly with real-time engines, and that's becoming more and more relevant as real-time engines improve. If you change the model, then you also need to redo all of your texturing, or you have to reproject details or something, because the PTEX works on a face-by-face basis, and anytime a model changes, the point numbers change, and the associated faces with this file also change. And so that requires reprojection if you want to change something after modeling has made its changes. So that's not convenient. And also, whenever you reproject, it may not reproject perfectly depending on how much the model has changed. Another con is that you can't leverage the benefits of third-party painting applications very well. Mari does support PTEX, and there are some others that do PTEX, but It's not as far and wide, and the features of those programs don't focus necessarily on PTEX like they do for a UDIM workflow. Also, it's not widely supported outside the Disney ecosystem. And so with PTEX, even though Disney makes a lot of its tools open source, you probably need to figure out how to make it work within your pipeline outside of Disney, and it's not going to just work by itself very easily. Also, it's not easily transferable to other apps, which is sort of similar to what I just said. And you can't use repeatable textures unless they are projected as triplanar projections. And for me, this is a big one. I think that repeatable textures are an insanely useful technique whenever you're trying to texture or shade something. And so the fact that you can't do that without triplanars is a massive con. And it's also not guaranteed that this triplanar projection is going to be a feature that's supported within whatever application or render engine you're using. And so even though it's possible to do a triplanar and set that as like some sort of painting on the mesh that then goes to PTEX, it may not be supported in certain applications. But I did forget one pro over here. There are no texture seams either, so you don't have to worry about that because it is face by face. So there you go. That's a little bit about PTEX. Now, how do I use PTEX if it's there, if it's available in the render engine that I'm working with? Well, if you use PTEX as a way of calculating ambient occlusion, it's really convenient within a triplanar workflow. Remember, the whole idea is that we're trying to avoid UVs. That's why you would use PTEX in the first place. And one of the issues with triplanars is that you can't really work in ambient occlusion without it potentially getting expensive for the render engine. Because when you go to render, you actually have to calculate that occlusion at render rather than have a map waiting there with all the information baked out. So if that's the situation you're in, doing edge signals, doing occlusion, that works great for PTEX. Otherwise, I really don't like to use it. And if you want to have something specifically painted on an object, it's better to just do a camera projection and to do whatever you want to do in Photoshop and then rely on triplanars for everything else. In the next video, let's talk about all the different techniques we've learned. We'll discuss some of the pros, the cons, and we'll wrap up this whole series.